Stardust, bringing cosmic history to Earth. Comets are believed to be the most ancient objects in our solar system. Made of ice, dust, and carbon, these celestial beacons are thought to hold secrets to the early formation of the planets and the Sun. When far from the Sun, a comet's nucleus is cold and its material frozen solid. As the comet travels towards the Sun, the ice begins to warm and the materials begin to evaporate, forming an atmosphere called a coma, creating an enormous tail which fluoresces in sunlight. One of these cosmic interlopers, Comet Wild 2, was the destination for Stardust. NASA's Stardust mission is managed by the Jet Propulsion Laboratory in partnership with Lockheed Martin and the University of Washington. The ambitious goal of this mission is an historic journey that will bring back to Earth the first ever samples of a comet. This 850-pound spacecraft was launched on February 7, 1999, aboard a Boeing Delta II rocket from NASA's Kennedy Space Center at Cape Canaveral, Florida. After 5 years and 2.1 billion miles of travel, Stardust encountered Wild 2 on January 2, 2004. As Stardust neared the comet, the spacecraft deployed its collector grid to capture particles of the comet. This tennis racket-looking device contains over 100 ice cube-sized compartments filled with the world's lightest known material, a silicon-based substance called aerogel. These comet particles, moving at 6 times the speed of a bullet, collided with the aerogel. With a heavier substance, the comet particles would have vaporized. But the light aerogel served to slow down the particles, capturing for scientists these microscopic clues to the formation of the solar system. But catching the comet particles required more than aerogel. The spacecraft had to do its part to soften the blow of capture by lowering its speed at time of encounter. Still, Stardust was traveling 13,000 miles per hour when it passed through Wild 2's coma, coming within 149 miles of the comet's nucleus. At such close range, the possibility of a larger piece of the comet colliding with and destroying the spacecraft was a genuine concern. For protection, shields were installed on the front of Stardust. Like a battering ram, the spacecraft made its way safely through the coma. Shortly after encounter, the collector grid was stowed inside the sample return capsule for the 2-year journey back to Earth. Another mission objective was to take close-up images of Comet Wild 2. Using a camera similar to those on NASA's Voyager spacecraft, Stardust delighted scientists with spectacular images of the comet's surface and features. By the time Stardust returns to Earth, the spacecraft will have logged 2.9 billion miles on its 7-year journey. That will give Stardust the NASA record for the farthest distance traveled by a solar-powered spacecraft. As it nears home, Stardust will refine its flight path with a series of maneuvers. Once in the proper position, the spacecraft will release the sample return capsule with its precious cosmic cargo. The next stop is Utah. The capsule will plunge into the Earth's atmosphere at nearly 28,000 miles per hour, one of the fastest re-entries ever undertaken. The friction of re-entry will dramatically raise the temperature of the heat shield, creating a glow in the early morning western sky. 20 miles above sea level, a small drogue chute will deploy, further slowing the capsule. 6 minutes later, the main parachute deploys, carrying the sample return capsule to a soft landing within the Utah Test and Training Range. After recovering the capsule, the Comet samples will be transported to NASA's Johnson Space Center in Houston, Texas, where scientists will first open this treasure trove of new information. NASA's STARDUST mission, helping scientists to unlock the secrets of the early formation of the solar system and our Earth. By exploring comets, we will discover the mysteries of life and beyond, as only NASA can.